July 9th, 1958, 10:16 p.m., Lituya Bay, Alaska. Howard Ulrich and his 7-year-old son are asleep on their fishing boat when a magnitude 7.8 earthquake hits. But Howard doesn't panic. He's Alaskan. He knows earthquakes. What he doesn't know is that 40 million cubic meters of rock just broke off the mountain above him, 90 million tons falling 3,000 feet into the narrow bay at 200 miles per hour. The impact creates a wave 1,720 feet tall, taller than the Empire State Building, the tallest tsunami in recorded human history. Coming at Howard's boat at 100 miles per hour, he has 90 seconds to live. This isn't myth. This happened 66 years ago. There are photographs, survivors, geological evidence you can see today on Google Earth. And in October 2024, scientists discovered something terrifying. It's happening again. The same geological conditions, the same unstable mountainside, but this time there are 12
fishing boats in Lituya Bay, 43 people,
3 cruise ships scheduled to pass within 5 miles in summer 2026. By the end of this video, you'll understand how a tsunami can be taller than a skyscraper, why scientists knew this would happen but couldn't stop it, and why the next megatsunami won't just destroy boats, it will hit the Alaska coast, where 150,000 people live. Stay until the end. What happened to Howard Ulrich in 1958 is about to happen again, and this time, the death toll won't be 2, it will be thousands. Lituya Bay is a T-shaped fjord on Alaska's southeast coast, 7 miles long, 2 miles wide, surrounded by mountains rising 4,000 feet straight from the water, steep, unstable, covered in glaciers. July 9th, 1958, 10:16 p.m. The earthquake strikes the Fairweather Fault running through Lituya Bay. The shaking lasts 4 minutes. At 10:17 p.m., the entire northeast mountain wall collapses. 90 million tons of rock, a face 3,000 feet high, half a mile wide. It falls into Gilbert Inlet at the bay's head. When 90 million tons hits water at 200 miles per hour, the water is pushed upward with the force of a nuclear bomb. The wave height at impact, 1,720 feet. If this hit Manhattan, it would wash over the Empire State Building and keep going. But Lituya Bay isn't open ocean. It's a narrow fjord. The wave doesn't spread, it funnels. It stays tall and fast, racing down the 7-mile bay at 100 miles per hour. 3 fishing boats are anchored at the bay's mouth. Howard Ulrich sees it first. In his words, it was not a wave, it was a wall, like looking up at a mountain coming at you. His anchor chain snaps. The boat lifts 100 feet into the air. He's surfing a tsunami with his son screaming below. The wave carries them over trees, over land, then drops them in open ocean, somehow still afloat. The Sunmore isn't lucky. The wave catches them. Broadside. Both crew killed instantly. Bodies never found. The Badger tries to run. Captain Swanson climbs the wave face, gets 3/4 up. The wave breaks over them. The boat flips. Swanson and his wife thrown into churning water. They find debris, cling to it for 2 hours until rescue. 2 dead, 2 survivors, 1 boat intact. And the evidence is still there. On Google Earth, you can see the scar where 90 million tons used to be, and the trim line where forest was stripped away, reaching 1,720 feet above sea level. The wave scoured the mountainside clean. That scar is still visible 66 years later. How does a landslide create a tsunami taller than a skyscraper? 3 factors: volume, velocity, confinement. Volume, 90 million tons. The World Trade Center towers weighed 1 million tons combined. This was 90 times that mass. Velocity. The rock fell 3,000 feet, accelerating to 200 miles per hour. That impact energy goes into the water. Confinement. This is key. In open ocean, waves spread outward and dissipate. But Lituya Bay is a narrow fjord. The wave can't spread. All energy stays concentrated. The wave stays tall, stays fast, becomes a battering ram. After 1958, scientists asked, could this happen again? The answer was terrifying. Scientists studied Lituya Bay and found evidence of 4 previous megatsunamis. 1853, wave height 1,200 feet. 1874, wave height 800 feet. 1899, wave height 600 feet. 1936, wave height 490 feet. Lituya Bay produces megatsunamis every 20 to 60 years. 1958 was 66 years ago. We are overdue. October 2024, University of Alaska geologists published a study using laser mapping to survey the mountains. They found 16 unstable rock faces. Any could trigger another megatsunami. The largest unstable section is bigger than 1958, 120 million tons. Perched on the same mountainside, destabilized by freeze-thaw cycles, glaciers that held the rock are melting due to climate change. The study's conclusion? A repeat megatsunami is not if, but when. High probability within 5 to 15 years. Between now and 2039, another megatsunami will likely occur. But 2026 is different from 1958. In 1958, 3 fishing boats, 5 people, remote. In 2026, cruise ships pass within 5 miles every summer, ships carrying 2,000 to 3,000 passengers. If a megatsunami exits Lituya Bay, it would still be 30 to 50 feet tall when it reaches them. A 50-foot wave hitting a cruise ship? Catastrophic. And worse, Southeast Alaska coastal towns are in the path. Juneau, 32,000 people, 90 miles south. Tsunami arrives in 11 minutes. Sitka, 8,000 people, 100 miles southwest, 14 minutes. Yakutat, 600 people, 80 miles northwest, 10 minutes. In 1958, 2 died. If it happens during 2026 cruise season with no warning, thousands could die. If scientists know this is coming, why no warning system? Barrier 1. Detection. Tsunami systems detect earthquakes and ocean displacement. The 1958 tsunami was landslide generated. Current buoys can't detect landslides inside fjords. Barrier 2. Speed. Even with instant detection, the wave reaches Lituya Bay's mouth in 3 minutes. Not enough time to warn anyone. Barrier 3. Cost. Real-time monitoring would cost $40 million. Alaska's disaster preparedness budget for the entire state? $12 million. The federal government could fund it, but Lituya Bay is remote, no permanent population, no political value, so it doesn't get funded. Translation. We know it's coming. We know people will die. We could prevent it, but we won't. What should exist? Motion sensors on every unstable rock face, linked to NOAA, Coast Guard, cruise ships. The moment sensors detect movement, alerts go out. Cruise ships change course. Coastal towns sound sirens. Fishing boats get 5 minutes instead of 90 seconds. Cost $40 million. 11 a.m. A magnitude 6.5 earthquake strikes. One unstable rock face gives way. 120 million tons. Larger than 1958. 11:01 a.m. Rock hits Gilbert Inlet. Waveforms. Initial height 2,000 feet. 11:03 a.m. Wave exits Lituya Bay. 150 feet tall. Enters open ocean. 11:06 a.m. Norwegian Sun cruise ship, 2,400 passengers, 6 miles west. Wave, now 60 feet tall, hits broadside. Hull ruptures. Ship lists. Lifeboats capsize in 60-foot swells. Estimated casualties, 800 to 1,200 dead. 11:13 a.m. Wave hits Yakutat, 40 feet tall. Fish processing plant obliterated. Harbour destroyed. Estimated casualties, 200 to 300 dead. 11:22 a.m. Wave hits Sitka, 20 feet tall. Historic downtown swept away. Estimated casualties, 400 to 600 dead. 11:30 a.m. Wave reaches Juneau,
15 feet tall.
cruise docks destroyed, downtown floods. Estimated casualties, 100 to 200 dead. Total dead, 1,500 to 2,300. Economic damage, $8 billion. All preventable. $40 million in monitoring equipment. That's the price to save 2,000 lives. But that equipment doesn't exist. July 9th, 1958. Howard Ulrich and his son rode a tsunami 100 feet high and survived. 2 people died that night in the middle of nowhere. But Lituya Bay doesn't care about obscurity. The rock doesn't care about politics. The wave doesn't care about budgets. The 1958 megatsunami was a warning. We photographed it, studied it, identified 16 more collapse zones, then did nothing. In 1958, 2 died because only 5 people were there. In 2026, 2027, whenever it happens, there will be 12 fishing boats, 3 cruise ships, 40,000 people in coastal towns. The wave will be taller, the impact wider, the casualties catastrophic. You now know what scientists have
Known since 1958.
Lituya Bay will produce another mega tsunami. The rock faces are unstable, the glaciers are melting, the earthquakes are coming. The only question, will we act before it happens or wait until we're counting bodies? If you're in Alaska, planning an Alaska cruise, or know anyone in Yakutat, Sitka or Juneau, share this video. Demand monitoring systems, demand warning protocols. The next Lituya Bay mega tsunami won't be historical curiosity, it will be catastrophe, and we'll have no one to blame but ourselves. Subscribe for the next investigation. If Lituya Bay can create a 1,720-foot wave, what else is hiding in Alaska's fjords? The answer will terrify you.